Hi, welcome back to our second video for 3.3 rational exponents. In this video, we're going to do an example where we have rational exponents in the form m over n. So no longer having 1 over n like we did in the last example, but having a number on top other than 1. So like 8 to the exponent 2 over 3. So before we start doing these, I'm actually going to give you the general rule. So if you have a number raised to the exponent m over n, what this means is we actually have something raised, a number b, that's our base, raised to the exponent 1 over n, and then all of that raised to the power m. So notice how I'm kind of doing like the power rule for exponents. A power raised to another exponent, we have to multiply the exponents together, and that would give us this here, b to the m over n. So it's like I split this up as 1 over n times m. That way when I multiply these, I get the same thing. And the reason why I'm doing that is because in the last video, we learned how to handle this, b to the 1 over n. Well, we just said that's the nth root of b. And remember, all of that is raised to the exponent m. Okay. We can actually leave this in this form, or we can actually write it like this, the nth root of b to the m with the exponent on the inside. So both of these are okay. That exponent m could be on the outside or the inside. They both still work. So the shortcut to remember is when you get something in this form, okay, the n, the denominator, is always the index, and the m is always your power that everything is raised to. So the m is on the top and it stays as the power. The n as a denominator becomes the index. That's how I remember how to do these. So let's start this first example. So we have 8 to the exponent 2 over 3. Well, if I follow that rule, the 3 is the index. Okay, so it ends up being the cubed root of 8 squared. Okay. I actually don't like it in this form. 8 squared is 64. I'd rather write it this way. The cubed root of 8 and all of that squared, because I could easily do the cubed root of 8. So remember, what number, okay, cubed equals 8. That's what this means. What number times itself 3 times gives me 8? Well, that's just 2. And 2 squared is 4. So that's our final answer. Let's do a quick check. Clear that all out. So 8, that's not 8. 8 raised to the exponent 2 over 3 is 4. So you can see that kind of all worked out. I believe this is actually how you're going to have to do all the questions on your calculator. Some calculators allow you, some calculators allow you to enter stuff in this form, but they have to be kind of a special calculator to do that. Most of the time, you're going to want to put them in this form when you want to check your answer. I don't want you guys to just kind of go from here to here, only if it's really easy to question. Otherwise, I do need to see a little bit of some kind of process to how you arrive at your answer. All right, part B. So I'll probably have to compress this afterwards. I'm just going to write big for now. So 81 to the 5 over 4. Well, what that means is I have to take the fourth root of 81 and then raise that to the exponent 5. Okay, I like to keep the exponent out and not put it in here. Just because 81 and the exponent 5, that's too big for me to do in my head. I'd rather take the fourth root of a big number and then raise it to the exponent 5 afterwards. So, all right, what number raised to the exponent 4 equals 81? Well, I know the square root of the square root of 81 is 9, and the square root of that is 3. So that's actually one way to think about it. So 3 times itself 4 times will give you 81. So whenever I'm doing fourth roots, what I actually do is I just do the square root twice. Okay. So I'll show you a quick little proof for that. the fourth root of something, you can think of it as the square root and then the square root again, right? Because if you do the power rule, a half times a half gives you a quarter. So that's a quick way to do the fourth root. You can do the square root twice. 3 to the exponent 5, that's not too hard. 3 times 3 is 9. 9 times 9 is 81, so that's 4. So one more 9, you get 243. 243. Okay, I'm just going to shrink some of this here a bit. Okay, so 49 over 81 raised to a negative 3 over 2. So that negative, if you remember the rules from the last lesson, when we have a fractional base raised to a negative exponent, all we want to do is do the reciprocal. Okay, so that's just apply negative exponent rule. Okay. So now the 2 on the bottom. So what this means is we actually get to take the square root and then cube it. So 81 over 49, and then we cube that. You might say, well, Mr. A, you forgot to write the 2 here. Well, I actually didn't forget. So we've never ever wrote the 2 here whenever we do the square root. So whenever you don't see a number here for the index, it's assumed it's a 2. Okay? So you can always do that from now on. All right, the square root of 81, well, that's just 9. Square root of 49 is 7. Cube all that. That's not too bad. 9 cubed is 243. And then, no, that's not 243. It's bigger than that. It's 729. 729, right? Because we have 81 times 9, 729. Okay. 7 cubed, 7 times 7 is 49, times another 7, almost 350. We got 343. So that's that. Let's do a quick check. So let's do 729 divided by 343, about 2.2. And let's put our original power in. 49 divided by 81 to the negative 3 over 2. And we get the same value. So you can see all the operations that we did were correct. Okay, that's it for this example. I'll see you in the next one.